I'm Andrew Brown. Welcome to Real-Time Music and Sound with Pure Data. In this video, we're looking again at the live coding toolkit for Pure Data. This is part of a series on the live coding toolkit. If you want to follow along fully, you'll need to download the live coding toolkit. It's available on GitHub at this site here. When you do download it, you'll need to go to PD's preferences and make sure that the path is set so that PD can see the folder which has the live coding toolkit abstractions in it. The toolkit provides some additional features on top of Pure Data Vanilla. So in this video, we're going to be looking at doing some chords and some chord progressions, and add some bass and drums to that, and a bit of an arpeggiated pattern. We'll probably use a little less randomness than I might have traditionally done. It's a bit more of a straightforward video. You'll see that we're also using Hydra, the web-based visual programming environment. So thanks to Olivia Jack for that. I'm also using Hydra MIDI by Arno Schliff to communicate between PD and Hydra. And the Hydra sketch that I'm using is based on one by Will Humphreys. So let's get started. I'm going to start by creating some chords. To do that, as we often do in the live coding toolkit, we'll start with a tempo object to give us a steady pulse, 116 beats per minute, and quarter beats, which is 16th notes. The output of that I'm going to put through a trigger object, because we need to just make sure that some things get triggered before other things do. I'm going to use the mod rand function so that we basically filter out some of the tempo pulses for the randomness. We don't want it to happen on every 16th note. And that will then trigger the creation of a random chord. There'll be 3 notes in the chord. The median pitch will be 55, the breadth will be 18 semitones either side, and then we'll give it a pitch class, like a scale, basically, to quantize the chords to. We will be doing some chord changes, and that's going to require some transposition. So use the trans object. We'll start with a 0 transposition and put in a scale or a pitch class set for that as well, to keep things within key. Once we've done all that, we'll send it out to the polysynth object in the live coding toolkit. Just give it some parameters, filter, and attack and release, and that will go to an output. The output's in stereo, so we just need to connect that up there, and we should be able to play some chords. Okay, so that's all going well. Just turn that down a little bit. I'm going to add in some random variation to the velocity, just to give it a little bit more interest. Okay, where's that going to go from? Actually, here. Every time a random chord is generated, also generate a random velocity. Take it out of the middle outlet, which is a Gaussian distribution. Okay, so now it's time for us to put some progressions on those chords. To do that, I'm going to use a cycle object to cycle through a chord progression. Start with some initial values, and we need to provide it with a list of the chord roots. In this case, 0 means in the original key, down 3 semitones, down a 5th, and down 5 semitones, like so. Come on in. Let's mark it. And then connect that in, click on it so that it has an effect. So this cycle output is going to go into the transposition, and then we can basically trigger that. So now you can hear that it's now changing chords by transposing as we go. Now I want to make sure that this cycle is in sync with everything else, so I'm just going to use a mod rand to get the downbeat every 64th notes. We can get that from here, and then we use that to trigger the or reset the cycle, so that's all in time with everything else. Okay, so that's our chords and our chord progression. I might turn my attention now to manipulating Hydra a little bit based on this. So we're just going to generate some random numbers. Actually, no, I need to get a message box. And this is going to be an input message to a line object, so that we transition, and then we're going to send that out via control message number 1. So that will then trigger whenever we get to that downbeat. Okay, so that's going. You can see we've got some effects on visually. It's changing subtly as we go. All right, so let's maybe add a simple bass so we get some fundamentals going on here. We use that to trigger a number box, like so. This is going to be also transposed in a more simple way, and then we'll quantize that, keep it in key. Send that out to the Live Coding Toolkit's FM synth. A few parameters for that, and then that will go to the outlet. Now I'm going to specify that that pitch should be 36. There we have it. And then we just need to make sure that that gets triggered every time. And you'll hear at the moment we're just triggering the pitch, but in order to transpose it, we need to connect the transposition up. Like so. So now we've added a root node or a bass to our chords. So I might introduce a little bit of drums at this point. So there's the drum kit that's just built into the Live Coding Toolkit. Some simple analog or some synthesized drums with an outlet. I'm going to provide some random variation to the velocity, in this case of hi-hats, and trigger those from there, and we'll also trigger the hi-hats. I like this a volume control for that, just turn it up slightly. Okay, and to give us a sense of a pulse, we'll grab downbeat every 16th note, and we'll send that to the kick drum. Okay, let's go back to a bass and add a little bit more of an interesting rhythm than just sort of a downbeat. To do that, we use the Euclidean rhythm generator. It's going to be a 16th note step. Start with 5-note pattern with no rotation. That needs to then go out into a cycle object. Give it some starting values. But actually this cycle object is going to be connected to the other outlet of the Euclid. And then we need to give it a list of pitches to play. So it's a very simple sequence. And then the output of that is then going to trigger that number. And so the final thing we need to do is just connect up our Euclidean. Don't need this one anymore. And put those pitches in. Okay, so that's given us a bit of a bass line. Let's go back to our drums and maybe add some snare into that. We will also use the Euclid pattern generator for the drums. It's again the 16th note step. When you want 2 hits, and we can use the rotation function to get it on the off beats. Again, we'll use some randomness on the velocity. So that Euclidean rhythm will trigger the randomness to go into our snare drum velocity. It will also, of course, trigger the drum itself. And then that just needs to be connected to the clock. So we've got a pretty straightforward drum pattern there. I'll add a few more sort of ghosting snare parts just to make it a little bit more interesting. So we're going to just take a small percentage of them and do some triggering of both the velocity for the ghost notes, which will be here. Ghosted note itself will be triggered in there. So now all that's necessary is for us to connect that up. So that's occasionally adding some ghosted snare drum hits. We're going to also now maybe adjust the Euclidean rhythm for the bass line slightly. Just the number of steps So obviously for a 16-step sequence, the values can be between 1 and 16. We can increase it slightly. And I guess in parallel to that, it might be nice to also increase the regularity of the kick drum. Okay, so that's going fine. I've got one last part to add, and that's the arpeggiation part. So I'm going to use the cycle object for that. Again, give it some initial values. I'm going to gate it so we miss a few notes out of that. And then we're going to send it to the polysynth object. Give it some default values. We'll send that out to echo to put a bit of delay on that. And then the echo will go to the outlet. Set up the stereo channels for all of those. So the pitches for our arpeggiation, we're going to take them from the random chord generator, but we'll transpose them up an octave so they're in a different range. So they're going to come out of there and then be transposed. So the last thing that remains is for us to just clock the cycle object. I'm going to increase the duration of that. And add some variation to the dynamics. Okay, so that's pretty much got everything going. So I might just pull a few bit of the parts out. Oh, actually, no, before we do that, we've got a bit more Hydra action I think we can add in. If we go over here, we can use the drums to trigger some of the Hydra changes. On the kick drum beats. You can copy and paste and do a similar thing, perhaps down here for our bass line as well. So if we get a bass note, change another parameter in the graphics. you can see we've got the graphics changing in time with our parts. Now it's time to pull a few things down and out. Okay, so there you have it. Thanks very much for that. Hope you enjoy playing with the life coding toolkit and with Hydra, and I'll see you in another video.